Okay, so I think we're recording. Got a student asked for help on this topic, and I'm going to try to bang out a video real quick before I go to class. So, the topic is calculating the solubility of an ionic compound when a common ion is present. I got some work to do. All right, let me come over here. I think I can scroll down a little bit. All right, so I'm going to make some notes here. It looks like it's lead 2 chromate in pure water first. In pure water, and then we're going to do lead chromate if we have some chromate in there also, right? That's the common ion. All right, so I'm going to come down here and say lead chromate. It's going to look like this. Lead 2 chromate, I think this is. Lead 2 chromate goes in a solution as lead 2 plus chromate. If I have that charge wrong, don't let me know. I don't really care. I probably should, but let's go here. Let's go here. This is a solid, right? And this is aqueous. And this is aqueous. You can let me know, whatever. But I don't really care. Okay. So lead 2 chromate. And so how much goes in the solution? Well, first of all, we know that whatever goes in the solution, let's say S goes in the solution, right? So we have pure water in the beginning. So if we have pure water in the beginning, we start with S, concentration of this stuff or amount of that stuff, right? And we start with 0 concentration of that and 0 concentration of that. Got some weird rendering here. Sorry about that. Looks like from another video maybe, but all right. So this is my initial, right? Initial change in equilibrium. There's my ice table. So if we have S in the beginning, and that's how much is going to go into solution, well, if that's how much goes in, then it all goes in. So the change is going to be minus S. It looks like this is a 1-to-1 ratio, so it's going to be plus S and plus S. Okay? So after we reach equilibrium, we have none of that left because that was what we were asking, right? How much goes in the solution? All of it. And so we're going to have S here and S here. So let's look up the equation for S. I'm not sure what's going on here. I've got something in the background maybe in this file. So sorry for the weird things jumping up there. So this is going to be lead 2 plus and chromate 2 minus, right? And so we're going to look up KSP. I'm going to pull the actual, this is the actual one I took a snapshot of. Let's go into data and find the solubility product of KS of, no, I don't want that. I need the numbers, the actual numbers. Solubility product constants, there they are. Okay, so let's go find lead 2 chromate. There it is right there. 2.00 times 10 to the negative 14. Okay, we'll come back. We'll bring it over again in a minute. This is equal to 2.00 times 10 to the minus 14. All right. Well, it looks like I can now replace those two. This is going to be S times S at equilibrium, right, is equal to that. It looks like it's S squared is going to be. All right, well, that wasn't so hard. So the pure water was not hard. Minus 14. The square root of 2 is 1.414. What is going on with this thing? Sorry about that. I don't know what that is there. The square, so S then is going to be 1.414 because that's the square root of 2 times 10 to the minus 7 because that's the square root of 10 to the 14. Okay, so that's going to be the first answer. We'll put that in. I'm going to bring this. Let's bring this over here to 2 sig fig. So it's going to be 1.4. 1.4 times 10 to the minus 7. Okay, that's it for that one. All right, but we got more trouble because now we have to consider what if we already have some chromate in there. Let's go back up and look at the question. What if we have 0.017 molar chromate already in there? Okay, so I'm going to do the same table. Would it be confusing if we did it with this one? Let's try it. Let's go here. And let's make this, instead of, this will be S. S is going to go into solution this time. We're going to start out with 0 lead, but instead of this, we're going to actually start out with 0.017 molar chromate, right? That's what the question said. 0.017 chromate. Lead chromate, I mean sodium chromate, I know, but the sodium is just a counterion. We don't care about that. So this then is going to, it's all going to go, this is a new S, right? It's all going to go away. It's going to go to that. Man, what is going on with my screen here? Okay, this is going to be 0. And this is going to be S. And this is going to be S. 0 plus S is S. And this is S plus 0.017. Okay, so I'm going to solve the same problem again, but this time I'm going to do it KSP. It's the same KSP. We still have that. It's that, right? Is equal to, now it's going to be S times S plus, what is going on with that? 017. What is going on with this? I'm really sorry. I must have something like in my clipboard for this pen. Okay, so it's going to be S squared plus 0.017. S is going to equal to, and KSP is 2 times 10 to the minus 14. Okay. Well, S is small, and so if S is small, this is going to be smaller. Let's call that 0. And so let's say now S then is going to be, oops, wrong color. S is going to be 2 times 10 to the minus 14 over 0.017. Okay, so I'm going to do this without a calculator. 2 times over 1.7 is 1, 2. That's going to be, this is going to be 0.17 times 10 negative 2. It's going to be 2 over 1.7 times 10 to the minus 12. Okay, and that's what S is going to be. That's how much we're going to get in there. And there's my answer for the other one. Oh, I'm tempted to do 2 over 1.7. What's that going to be? 2 over 1.8 is the same thing as 1 over 0.9, which is equal to 1.11. 2 over 1.6 is the same thing as 1 over 0.8, which is, I can't do that in my head. I just can't do that in my head. Yeah, I can, yeah. 1.25. So it's going to be in between there. Let's say it's 1.2. 1.2 times 10 to the minus 12. Okay, I think that's what our S is going to be. Let's do it in the calculator now. Let's pull this guy over here. Calculator. 2 times 10 to the minus 14 divided by 0.017 is equal to, and the 2 sig figs, that's it, 1.2, yeah, times 10 to the negative 1.2 times 10 to the negative 12. So let's go ahead and put that in there. 1.2 times 10 to the minus, ooh, those were concentrations. Those are not grams per liter. Ooh, man, I gotta fix that. That was a mistake I made in class yesterday. I'm gonna do that again. Okay, so I am not sure what's going on with that mess over there. Let's come over here and let's just say, okay. So, but this is concentration. I was supposed to do grams per liter. 1.17, still in my calculator. 6, whatever, dot, right? This is moles per liter, and we want grams per liter, so we got to do grams per mole. come over here and find out what the molar mass of lead 2 chromate is. Molar mass of lead 2 chromate. Lead plus, oops, clear. Uh-oh, undo. Store. Clear. Lead. Yeah, lead's right there. Lead plus Cr plus 4 times oxygen equals 323. Store, okay? 323. And so let's take that over there. It's going to be 1.16 times 10 to the minus 12 divided or multiplied by, and what was that number? Where did that number go? Multiplied by 323. Is equal to, it's just those two numbers put together, isn't it? This is clumsy, isn't it? Sorry. Times that other number. Store scientific. 3.8 times 10 to the minus 10. 3.8 times 10 to the minus 10. Store. Clear. So this was, that was in concentrations, but I was supposed to do grams per liter. 3.8 times 10 to the negative 10. Now let's convert this one to that, okay? I said I did the square root of 2 because I'm used to that one. 2 square root, well, clear. Square root 2 times 10 to the minus 14. And we said, that's what we said, 1.4, okay? Store. And this is also going to be a concentration in moles per liter times that number equals 4.57 times 10 to the negative 5. 4.57 times 10 to the minus 5, and I better get rid of this other number here, huh? Okay, and I think that's it. Wow, clumsy video. Check the number of sig figs. Oops, 4.6. Clumsy video because I had some technical problems here. I was trying to rush so we could get this off to class. All right, I got to go to class. Hope that's helpful. I'll post this video and ask for another if you'd like one. Good luck to you.